Hi guys, welcome to another tutorial on Untitled Tutorials. I am Josef Botnar. I'm continuing the Java tutorials. This tutorial has the goal to talk about floating point types. I come again here on this website, W3 Schools, because here you can find some free information about Java and explicitly about Java data types and this type of floating point types. So there are two categories, float and double, regard to these floating point types. If you go down here, you can see that the float, the range of value stored by this type float, it is this one. And you have to add this letter, either lowercase f or uppercase f, to the end of the value, which you are using to initialize or assign a float variable. Also, the floating point types need a number with a decimal, yeah, and here you have two examples. So any decimal number contain a decimal point and is followed by decimal digits after the point. Alright, so another floating point type is this double. This is the range of value which this type can store. And optional, you can add this letter, lower or uppercase D, to the end of the value, which is used to initialize or assign the double. Very important is the precision of floating point, which indicates how many digits a floating point type can have after the decimal point. Yeah. The precision of float is up to 7 decimal digits, and for double is up to 15 digits. Is written here, but now I made a check and there is actually 16 digits. Let's make an example. In this way you will understand better how this floating point types works. In order to declare a float type, you are going to use this keyword float, yeah, and after you write the name, I'm going to use this letter A, and either you initialize this variable here using this equal sign and write a number like 4. Yeah, this is a whole number, so I'm going to initialize this float type with a whole number, what we can do without any problems, yeah, or semicolon and go on another line, and you can initialize this variable here with this number 4. The same thing you have to do to declare a double variable. I'm going to name it B, and I'm going to assign it with 4 whole number as well. Now here I'm going to declare an integer init type variable, and I'm going to name it I, and I'm going to initialize this with this same whole number 4. Let's display in console the result using the system.out print line statement. And I'm going to write here float type, yeah, plus and the float variable A, semicolon. I'm going to copy and paste twice this statement. Alright, and here I'm going to use the double variable, and here the integer variable I. Let's execute this up and let's see what we are going to receive in console. So as you can see, here is the result. I have to change here. So this is double, and this is integer or integer type. Yeah. Okay, so as you can see, let's run it again to have the correct result here in console. Here you go. So either for a float or for double, we received in console 4 decimal point and 0 after decimal point. Yeah, and for the integer we received only the whole number 4. Why this is like that? This is because the Java compiler knows that these two variables a and b are floating point types. The a is float and the next one is double, and that's why even we have used to initialize them with the whole number. The compiler will add this decimal point and 0 after decimal point, because the compiler knows these two variables are floating point types compared with the integer type. Yeah, so bear in your mind this. I'm going to remove this statement. Yeah, and here, for example, let's add the decimal digits. I'm going to add this decimal point, and after bit 35. As you can see, I received automatically error, and I went over of this real number with my cursor, and IntelliJ displayed this notice: required type float. We received errors. As you can see, we have this curly line here, yeah, because we have to add to the end of this value f, because this is float type or uppercase f. And now if I run this up, I have to remove this one as well. Now let's run it again, and here is the result. Yeah, I received for float type 4.35. so now the result is correct. All right, and if I do the same thing for a double, I'm going to add decimal point and these two digits after decimal point 35. Let's run this up. Here you go. I received the correct result, 4.35. Even I didn't add anything to the end of the value. As I told you, for double, as the Java compiler interpret all the real numbers as a double type, you don't need to add here a D lowercase or a D uppercase. This is optional in this case. Yeah, you can use, if you want, this D letter, up to you. It says it is a good practice to add the letter when you initialize or assign a value to a double variable. Yeah, all right, let's remove these two, and now let's make this variable a, which is a float type, to store this division between two whole numbers, 5 and 4, and the same for a b variable. Yeah, 5 divided by 4. Yeah, semicolon. Let's run and let's see the result. As you can see, we don't receive errors. The both types has this result 1.0. Yeah, because the Java compiler does the same interpretation as it did when we initialize these two type, float and double, with whole numbers. Yeah, so if we want to receive the correct result here, we have to add f letter to the end of these two values, and here we have to add D. Let's run it, and here is the result of the division. Now this result is correct. Now let's use here 3 because I'm going to show you something, and here again 3. Let's run it again. Here is the result, and now we can check the precision of these two types, float and double. Now this is the float, and here is the precision after the decimal point. So let's count: 1, 2, 3, 4, 5, 6, 7. Yeah. So this is the precision of this floating type. It can store up to 7 digits after the decimal point. Regard to double type, let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. As you can see, the precision of this double type is double compared with the float, and the number of the digits after the decimal point is 16, up to 16. So the precision of double type is higher than a float type. That's why mainly you want to use real numbers in your application. You are going to use this type, mostly the double type, and not the float type. Okay, so let's remove these two, and let's continue with a few examples. Yeah, so let's write in this way a real number, 5.0 and 3.0 semicolon. As you can see, I received error. When you see this bulb with this red color and this exclamation symbol, yeah, you have solution here. One of the solution is the cast, but I didn't talk about cast, but just to give you an example, you can use a cast, and this will add in the front of division this keyword float inside parentheses, and now we can run this application. But first let me to remove this statement, and here is the result. Yeah, the result is correct, but I wanted to show you another solution, and another solution is to add the F letter, yeah, to the end of both. And now this will works. But let's see here. Here, if I add 45 and here 35, as you can see, I don't. Let's remove first this. I don't receive error. Yeah, let's run the application. Okay, I have to remove the comments here. No, not here. Here. All right, let's run this application. All right, and here is the result. Yeah. So as you can see here, using the letter to the end of the values is optional. I can do it, no problem. So I'm going to receive the same result, as you can see. Yeah. Also, you can use the integer variable to store the result of division, but let's see what is going to happen if you're going to use an integer variable to store the result of a division. As you can see, we don't have errors, so let's remove these comments. Yeah, let's run this application. Here you go. This is the result of division, which is stored by this variable I. Yeah. So as you can see, the compiler displays just the whole number. Actually, the compiler removed the decimal part together with the decimal point. So this is the kind that the integer type will store the result of the division if the result of the division is a real number. So that's all for now. Thank you for watching this video tutorial. I'm waiting for you to watch my other video tutorials. See you next time. Bye bye.